Do backend developers like CSS?
I will say it is my least favorite programming language to write. CSS is also basically not a programming language.
This is Lane Wagner, and he's actually kind of a serious backend developer.
Assembly, particularly like ARM assembly, which is what I learned in school, I mean, it's simple.
He also runs the Backend Banter podcast, and his actual profession is teaching people backend development through his own company, boot.dev. So we had him on the Bad at CSS podcast to figure out what exactly backend developers think about CSS.
I'm a backend developer, and I'm just going to use Bootstrap. JavaScript land is nuts. This is the nerdiest thing I've ever heard, which is incredible coming from a backend developer.
So get ready for a real and actually balanced discussion.
Welcome to the Bad at CSS podcast. We've got a guest today, Lane Wagner, SLC punk, backend go rockstar. He's not a businessman, he's a business man. He's a teacher, indie hacker, toot maker, and I mean tutorial maker, and lead on boot.dev, already helping millions get a bad backend career. A rad backend career, a bad backend. You don't want one of those. That's what I have. I'm 40. You don't want that. But welcome to the Bad at CSS podcast, man. What you bad at in CSS? It could be everything. I don't know. You tell me.
That was the best introduction I've ever had. And I've been on 20 podcasts at this point. That was incredible. The only criticism is it sounded like you said the baddest CSS podcast, which I guess could be interpreted as good or bad.
I love that our logo looks like we said badass podcast. Everyone's like, it looks like it says badass. And we're like, yeah, it's kind of, we like that about it.
Well, I am bad at CSS. I'm the perfect guest, I think.
So I've been very excited to have you on because Adam was telling me, I was talking to this guy on his podcast, and he was telling me that he thinks CSS is harder than assembly. Both Adam and I laughed at that because we were like, ha ha ha. But no, it can't be. So I need this take here. How and why is CSS harder than assembly?
So we have to be very careful with the word harder. It's not harder to get useful things done in CSS. That's definitely not true, right? If you're trying to do useful things, it's definitely going to be easier to do that in CSS than in assembly. But assembly, particularly ARM assembly, which is what I learned in school, I mean, it's simple. Almost definitionally, it has to be simple. There's not all that many instructions. There's not a gigantic API to learn. There's not radical changes happening every year when Chrome decides to add new features, right? So from that standpoint, assembly is a lot easier to learn the basics of. And well, I shouldn't say to learn the basics of. There's just not all that much stuff happening in assembly. You can learn the whole thing. Now, of course, building Roller Coaster Tycoon in assembly is not easy. It'd be very, very hard. And it would be wrong to say that that's harder than, styling a landing page with CSS. But yeah, to go really deep and understand the nooks and crannies of CSS, very difficult. I don't know the nooks and crannies of CSS. I know the high level stuff, or I should say the basic stuff.
We're still learning too. Don't worry.
Yeah, no. I still need to learn anchor positioning. So that's
that one is sick. I've been exploring that one the past couple of weeks. We just it's good. It's so good. I got rid of position relative on something and then just got to anchor it. And I was like, I love deleting position relative. I love it. Just like I like deleting float. I'm like, yeah, get out of my life. I don't need you no more.
New? You guys got to explain this to me. Anchor positioning? Tell me about this.
Adam will have to be the one to explain it to you.
All right. The basics are you have two things need to participate in anchor positioning. You have the anchor, which is the thing that doesn't move. All right. You could think about it. It's like the thing you dropped off the boat, right? It fell to the bottom and it's stationary. And then you have a boat that's anchoring to it. And that's what we call the positioned element. And so you just give any element you want. You just say, here's my anchor name. And you say dash, my anchor, and then any other element, and it can be position fixed, position absolute, anywhere in the DOM. Doesn't have to be a child or none of that shit. You can just say anchor to that other one. I want to be on top, and it's on top. And there's all these keywords for
tooltips, I imagine, right?
Yes, and it even has a handy keyword that's centered on top, and it'll allow the tooltip to widen and shrink and always stay in the center. It also has capabilities called auto flipping. So let's say you put a tooltip on top and you scroll up and the element and the tooltip is about to exit the viewport. It will flip to be on the bottom. It's like a complementary flip. So if you positioned it with top, it knows that to flip would be to go to the bottom. And so as you're scrolling it out of view, it flips to the bottom to stay in view. And then as you scroll it out of view, there's another one called position visibility. And you can say, hey, if the anchor is not visible, then hide the thing attaching to it. And the thing that's attached to it just hides. And it's glorious. It is so glorious. All these keywords, all of this noise that we were doing with JavaScript to get this behavior is just baked into these succinct, terse, amazing little anchor APIs.
That's new, I'm assuming.
Yeah. And it's gone through some thrashing. Chrome early shipped it, and then there were some like working group discussions, and now we're in like the tail end of updating all those things. And then they're working on Anchor level 2, which is going to bring even more stuff like a tether, like the little dingled triangle, that helps you orient, like, what's this thing attached to? You got like a little tooltip with a little down triangle thingy. Yeah. So we're calling that a tether. And so what's hard about this, like that flipping technique is really cool, but you're like, how do I position a tether to also flip to the bottom, but be on top when it's underneath type of deal? And so that's coming in the level 2 of the spec. You'll be able to add a dingleberry, and it'll be a perfect dingleberry every time.
What word choice?
It's in the spec, though.
Yes.
Oh no! That's really cool. You like building tooltips is kind of a nightmare. We like on boot dev, we were originally using like some, when the project was like really new, we were using some off the shelf like NPM package, and then we wanted a lot more custom styling and stuff, so we rolled our own. And there's a lot of edge cases. Like you just got to write a lot of code. At least you had to. So cool. I'll be checking this one out.
Yeah, it's rad. It works really great inside of nested scroll views. It's really good too for commenting systems. It has another function called anchor size. And so the positioned element that's trying to anchor to something can ask that item what size it is and use it in a calc and be like, I'm double the width of whatever I'm attached to. I'm half the height or whatever. And it just enables all, and then it can also be spatially aware. So you can have it positioned to, so the position element that's floating can have its left side positioned to the button and its right side positioned to the right side of the page. So you can anchor different edges to different elements, and it makes that like Google Docs commenting system trivial, where they stack under each other. They're like contextually aware. Oh, dude, it's out of control. Be excited. That was good stuff.
It's radical. This is the nerdiest thing I've ever heard, which is incredible coming from a backend developer.
So yeah, like as a backend developer, so I once worked, I still do, but I once upon a time, I worked very heavily with a backend engineer. In the early Firebase days, we launched Firebase hosting, and pretty much Chris Rayner, shout out Chris Rayner, he built so much of the Firebase hosting system, like kind of himself. And so he set up all the backend development with the CDNs and the cache purging and all this stuff and deployments and blah, blah, blah. And then he went to build the CLI and pretty much told me that this was incredibly difficult. Like, I'm like, he just basically built a system in which anytime you deploy your website, it will purge the cache and this is in 2013. It would like purge the cache everywhere in the world, and boom, now you got your site all in these other spots. So it's like, it was pretty amazing. But a Node CLI, oh my God. And he considered that the front end. He's a very back end developer. So Node CLI is front end for him. But he told me,
it is front end. I mean, definitionally, come on.
As a CSS developer, you're like, Node CLI has backend development. But he told me what he found to be so difficult about building front-end systems that are backend systems. So with backend systems, he can basically set it up as like a function where it's like, these are my parameters. This is the input. If I have too much of this, I can compensate for that. And I can always like, my problem will be like resourcing before it will be like not understanding what will happen. Like I know what will happen. He's like, but on the front end, he's like, I have no idea what's going to happen. He's like, I feel like I cannot prepare whatsoever for what comes my way. And he's like, if it's a function, he's like, the parameter list, the argument list is just like, he's like, it's too long. You can't see the end of it. And I've always found that to be like an interesting comparison between the two. And I was going to ask you, is that sort of your take, or you have anything kind of like some familiar insights doing both?
Yeah, I think there's kind of two sides to that coin when it comes to like whether something's like easier or more difficult to test based on the environment. So I think it's absolutely true that the environment in which your front end code will run, whether it's a CLI tool that you're shipping, which, in a lot of cases I would consider a front end, especially if it's like a CLI tool that interacts with a server and that's its primary purpose. Something like, the G Cloud command line tool or the AWS CLI. Those are very front end. Like it's going to depend a lot on your environment, what stuff you have in your path, right? Config files that need to exist in specific locations, different operating systems. Like you have to take all that crap into account. And then the same goes with, web front end development, different browsers, different APIs that are available. So like that's a nightmare that we just don't have to deal with on the back end because we control the servers. So in that regard, backend development is easier or at least simpler. But then there's this other thing, is that like doing like end-to-end testing, I'm like kind of in quotes, end-to-end testing on the front end, way easier than on the back ends, especially if you're trying to like simulate real world load and stuff like that. That can get really
you don't have to. You don't. Yes, and also a load test, or I don't even use the term load test, but a heavier integration test for front end is usually like a lot of clicks or like repositioning or adding things, whereas like a load test,
you have a QA person click through the UI, like that's your end-to-end test. It's
you can use Cypress too and do all that type of stuff. But with backend development, while there's tons of tools and stuff for that, I mean, load testing itself can create like a large bill. Actually, load testing can create a bill larger than like your first like week of usage is going to be, because you want to make sure. And one of the cool projects I helped out with, like very tangentially, was when Firebase Cloud Messaging, massive push notification service, they had to do all this preparation for the World Cup. And as you imagine, lots and lots of push notifications sent during that time, like sort of an unimaginable scale. And they wrote, I helped them out basically with this, doing images and kind of setting a narrative for this blog post. And as they were describing to me the things they had to do to prep for that, and they were talking about how the load testing on the back end would be so complicated because most traditional load testing, and sorry for those who are listening, it kind of goes like a parabola, sort of like if you're like, hey, look, it spikes up and we handled it, now it's going down and we handled that and we're really good. But they're saying like that's not what load looks like, especially during events like that. Like when the goal is made, yes, you get something else, but then he's like,
it's a straight line up and then an immediate fall off 60 seconds later.
He's like, you're hitting these weird gaps. And I made this image that was really interesting, where it showed like where you could basically be missing how you could handle certain types of load. And that's where like people fall off on load testing, is that they just do like a very traditional, like we handled the huge load, so therefore if we can get this high on a load, we'll be fine. And that's not the truth at all. Like there's so many more variables, but even at that, it's kind of cool that you can simulate and do that in a way that I think actually you can't really do in front end development.
And I will just point out, because I'm assuming there's a lot of people listening that don't work at Google, like if you're working as a backend developer at a smaller company, like just handling that very traditional spike might be a pretty good map pretty well up to your reality. And so doing all that extra stuff is, I would argue, kind of a waste of time. But yeah, like you just need to know how your system typically spikes in usage and what that looks like, and then test for it. So
one thing that you have me thinking of talking about assembly in CSS is that if assembly is harder than CSS, in certain aspects, does that make Tailwind a higher level programming language? CSS is the it's got its like malloc and all that. I don't know my assembly.
It's malloc and free,
stuff. Yeah, exactly. And it's doing all the stuff. And Tailwind is just like, it's the C on top of that, or I don't know, or is Tailwind like Visual Basic? I don't really know how high up the chain we're going here.
How pro Tailwind is this podcast audience? Just out of curiosity.
I mean, I started out when Tailwind was very young, like in 2017, 2018, whenever it was first out, like in its alpha days, using a ton of it. Like I built my original or one version of my personal site with it. I love Tailwind. I don't like the view that Tailwind fixes CSS, or that I don't need to know CSS because I know Tailwind.
Yeah, I'm pro Tailwind. I think there's a lot of great benefits for it. I mean, the style sheets people are making with it are really nice and tidy, short selectors. I mean, it's got lots and lots of really good things going on with it as a methodology. And I'm with David. Some of those things are annoying to me. Like, I don't mind escaping out of the Tailwind paradigm here and there, especially because I'm quite opinionated. But for me, it's like it got really harder with the tooling. Like I liked 1 and 2 when I just sort of like grabbed a style sheet and I was like off to the races. But I do like the JIT compiler. I like the way that it's sort of being additive instead of subtractive, because it was annoying then to sort of reduce the bundle after you got it. But yeah, Tailwind positive here.
Okay. So here's kind of my thing. So I've always been a backend developer, but I've always been building side projects. And to build side projects that you want people to use, turns out sometimes you need to write some CSS. So, I started out with like Bootstrap, again, because I was like, I'm a backend developer and I'm just going to use Bootstrap because that's what you do when you're a backend developer. I hated it. Didn't like Bootstrap because I always wanted to do something different. And Bootstrap this is the thing that has always bugged me about, especially, I don't think this is much of the case early on, and definitely probably not people listening to this podcast, but you'll hear developers say things like, I hate CSS frameworks because it like locks me into this thing. And that's like true about Bootstrap, right? That's like the whole purpose of Bootstrap is it's a style. The thing I love about Tailwind is it's not a style. It's more like a philosophy of like how to write clean CSS. It's almost like, not that I'm, saying the methodologies have equal value, but you could almost think of like Clean Code by Uncle Bob Martin as kind of like Adam Wathan's like view on Tailwind. I actually read his book Refactoring UI before I ever even knew about Tailwind.
It's a great book.
And it was like, I loved a lot of the stuff in that book. And it's like, if you agree with a lot of those philosophies about how you should just like write kind of clean, maintainable, and usable CSS, Tailwind is kind of naturally follows from that. So I'm a big fan. I drop down into CSS anytime I need it, which does happen. And I like that, for the most part, they don't really conflict, which is great. Boot dev is a very custom style. If you ever have visited the website, it doesn't look like Bootstrap or anything. It's very custom, and it's for the most part, it's Tailwind. So I guess to get down to your actual question, which was like, is Tailwind kind of like, I guess the way I think about like lower and higher level would be something like, okay, if like C or assembly is lower level, then like, Python's maybe higher level. I don't really think of it too much that way. A big reason for that is like when I learned Python, I learned a lot about coding and computer science and programming basics, but the lower level details, like again, about like memory management, malloc and free, all that was abstracted away. And I didn't learn about it until I explicitly went down a level to learn about it. I feel like with Tailwind, like you kind of just learn CSS as a natural byproduct of using Tailwind, which is fantastic, which you can't be said of other libraries that, again, are very prescriptive about style, things like Bootstrap. Like, I don't think when I was using Bootstrap, I was really learning all that much about how to use CSS. I was really just kind of trying to take a styling shortcut because I was a bad designer. So, I'd say it's a little different.
That's a beautiful answer.
I like it too. I'm thinking over here like underscore and Lodash, like those don't have the learning JavaScript benefit like Tailwind offers to a CSS author, right? They're both kind of utilities that you import and they give you all these things. But with Tailwind, the name is so close to the property value that you're using that your brain kind of just learns to minimap and micromap like these short names to the long form thing. And that doesn't happen with Lodash. Or underscore, right? You're sort of like using group by and you're like, I don't know how group by is working, but I want to group by this key, if somehow Lodash, it gave you these things and exposed it to you more, like maybe if you copied and pasted it into your project instead of just importing it and using it so high level. So yeah, Tailwind does sit in this fun middle ground where I genuinely think, well, and yeah, you have to be in the mentality and you also have to not be copying and pasting too much, because if all you really do is copy and paste components from presets, you're not going to learn UI. But then again, that's not your goal at all either. You're not trying to go custom at that point. You're trying to just, and also I like that Tailwind shows you the composition in the class name stack there. So you kind of get to see how all the pieces and parts and bobs and effects all come together in a nice little view. Yep, it's good stuff.
That bit on the learning is interesting. And like you mentioned Lodash, which I'm not familiar enough with Lodash to make like a really good comparison, but maybe a similar comparison that I think is similar is so we teach Python on boot dev, and there's like, a dot sort method or a sorted function, and we have lessons on boot dev where we're like explicitly trying to teach how sorting works, right? Not because you're going to be writing a lot of sorting algorithms from scratch, but like it's good to know that like sorting lists is an order n log n operation, and here's why. And it's also just really good kind of brain teaser practice to get you thinking algorithmically. And some people pop in and they'll be like, define bubble sort, first line, list dot sorted, return it, right? And they're like, my solution's way more elegant than the solution given by like boot dev and the answer key. Mine's only one line. It's like, yeah, but you didn't sort anything by yourself. Right. So there's like, there is this idea when you're learning about finding the level of abstraction that isn't going to hinder what you're trying to learn. Now, that doesn't necessarily mean like if you're not trying to learn how to sort, then yeah, by all means, use the built-in. But especially when you're new, trying to be very aware of the tooling that you're using and whether or not it's helping you understand fundamentally the stuff that you're working on is important because it's not always obvious.
Adam, do you think you could implement bubble sort off the top of your head?
I could implement a sort that bubbled things, and I don't know if it would match the computer science.
It would be bubble sort. If you invented an algorithm for sorting on your own, it's bubble sort. That's the one you will invent unless you're a genius.
Bubble sort is the one where you literally do like each one only goes up or down in the array, right?
Swap.
And it just kind of trickles, and then it reruns and it continues trickling until it's like doesn't have any more pieces to scoot. I think that's like the proper bubble sort, but I would have cheated and just sort of like reduced and then just inspected everything and figured it out and just been like, all right, I didn't bubble anything.
There are slower ways to do it, but it's like one of the slowest and simplest ways to sort. Yeah.
Probably could only do bubble sort off the top of my head if I sat down with like a group of objects, like, I'm having to like, and I could physically do bubble sort in my head. And then from there, I'd be like, okay, all right, now I can write the code. Like, I don't think if someone like just looking at like a blank file, I couldn't do it. But if I, for most sorts, actually, I think I could do that. I'd be like, oh, what's the thing with merge sort? Like if I physically do it, then, I can write it. But it's, that's actually, I remember in school, the only thing that helped me with sorts is when, we all stood up in the front of class and physically sorted ourselves according to the algorithms. And then I remember being like, okay, now this makes sense to me. Like, okay, all right, this is fine. Before then I was like, this makes no sense.
I love reenactments like that. It's so fun. And there's even one, I really want to do a video with Jason Langsdorff where I sit down at my computer and I npm install next or whatever, and then all of a sudden like 4 different people show up over my shoulder, and like one of them's the linter, one of them's Husky that's watching my Git commits, another one, and then we're like, oh, okay, hold on, I need to add a style in. I add a style in, another person's head comes up, and they all just start whispering to me the whole time I'm typing. Are you sure you want to type that? Hey, I know you're half done typing that word, but it's wrong in its current state. And I'm like, shut up, like eventually, like, and then, but I'd love to see it next to another dev, like some dev that's just like loves them, just like, oh, you're right. Thank you so much. Because there's so many devs that they stack on 10 to 15 different tools that are all, Copilot mixed with this, mixed with that. And I'm like, that's like 10 different people over your shoulder telling you what to do. And that drives me nuts.
This is so
it's like just seeing these 2 different juxtapositions of developers, one of them in love with all the 10 heads behind them, and one of them that's just like, get off of me before I backhand you and delete you off my machine.
I love the tools at the right time. So like, I hate Husky, for example. It's like, shut up, I'm going to commit this. If my commits are bad, I can fix it later before I open a pull request to go into everybody else's repos. But like, I'm local, I do local. Same with like the tooling that will like tell you you're typing it wrong, but you haven't finished typing it yet. It's like, well, I don't want to format it now. I want to format it. I'll format it later. I'll format it on save or something.
TypeScript would be the one over your shoulder being like, that's not gonna work. No, you need to change.
That shit might be null. Did you know that? Did you know that might be null? Hey, it might be null. You really should check if it's null or not. I'm like, dude, shut up. I'm not even done completing my thought. Get off of me.
Like, we can't be certain we know what that's going to be. So, like you're going to need to clean that up before you can write the next line.
That is so funny. Yeah, personifying all these things is really fun.
So with Lane, you have lots of backend experience. If you're talking about writing in Python, teaching Python, you told us previously before we started, you're a Go developer. You talk about assembly. Could you give me a list of your top 5 most difficult backend languages that, with your experience, anyone could put brainfuck or like Haskell or something weird. To me, brainfuck and Haskell are the same, but what would your 5 be?
Most difficult? I mean, if I don't like them, I don't work with them is the problem, right? So it's like I've worked with several that I've been like, I don't want to do that anymore. I'm just not going to do that anymore. So like the most hated, again, I don't know if I'd say difficult necessarily, but I don't enjoy working in Java. It drains my motivation to do anything.
Yes, share us your hate. Show us your hate.
It's not just the language or the tooling, which are abysmal already, but like the culture surrounding Java is disgusting. And I mean, not like the human culture. That would be very rude and probably cancelable to say. Not that. The coding culture, the technical coding culture. Like I hate the endless factories and abstractions and solid design principles that come with it. I hate all that stuff. So Java for me is that's the last one. I would go write PHP before I'd write Java, and I'm not a fan of PHP. So that's I think those are the only 2 I could really, really complain about.
So you're not a fan of having an abstract factory solver create abstract factory method?
I'm not a fan. I like defining struct literals in Go. They're very simple things. It's a group of fields, and you're done, and that's it.
There is a site internally at Google where you can, I can't remember what it's called, but basically you can look up what the longest method names are in code base index in Google, and there's you can see it pyramiding down, pyramiding, but sort of sort of descending down, and I can't remember what the longest ones are, but they are scrolling, and you're and they are following the convention, because a lot of times I'm why would you make it that long? And it's that's the rule. There is no choice not to.
Yep. Working at Google, I could be wrong. Were Google's backend systems primarily written in Java before all the Go stuff?
Yeah, I mean, from what there's a lot of Python.
I thought it was
Java.
Python. Yeah.
Yeah, there is a lot of Java, but also a lot of Python. I remember when I joined in 2014. I had that same sort of idea, it's got to be Java, it's got to be a ton of Python, and all that's true. But I mean, it's a large company, so a lot of code. But I remember someone told me that this is in 2014. I have no idea about the stats now. They're the largest, the most common programming language you use, more lines of code, is JavaScript, and that's just because and also I think it's funny that so much of Google's past, I think now it's not there, but it was trying to not write JavaScript, GWT. This makes me so sad because I'm going to say GWT, and I'm fairly certain there's a lot of people listening to this podcast right now who are what is GWT? And
you're not saying JWT, you're saying GWT.
Yeah, it's the Google Web Toolkit. Yeah.
GWT. That's how it's lovingly known. Google Web Toolkit, which was building, which when it came out in 2008, was considered so ahead of its time, and you could write Java, and create websites with it. So it sounds like a perfect tool. You should rewrite boot.dev and GWT.
Literally, the only thing worse than JavaScript is Java. I can't.
And what's amazing about GWT though is that the tooling in GWT was so far ahead of its time. Even to this day, it actually is. They would be able to minify all of your JavaScript classes based in the HTML, based on your style sheets, and it was able to, and it was a front end. It was a whole full stack framework, and so any like any payloads you'd send down to the client would be able to get like analyzed, and they would cut like unused properties and things off of stuff. So it like from a tooling standpoint, it was actually kind of mind blowing how much it did that we still actually don't have today. But yeah, it was all in Java, so it was kind of doomed from the start to be. I mean, it was really popular for a long time, but I think its longevity was doomed from the start with that decision.
I hate Java too. It was one of my first programming languages that I built anything like substantially with, and I couldn't wait to get out of the typed strict hell that it brought me.
Well, that's the wrong reason to hate Java. You're hating it for the wrong reasons.
There's plenty of reasons. I agree, but yeah, I was just like, it's just so much work. There was so much to type all the time. And then, okay, here's a question for you, Lane. Curly brackets after your function name on a new line or right after just on the same line?
New line is unhinged behavior. They absolutely this line. Yeah.
All right, we could be friends. Okay, yeah, it is when you see like if, and then it's like the brackets like right below the if. Like I'm always like, it looks like the code's broken. Like it actually, I know it will run. I know it will run, but part of me wishes it wouldn't. Like, I'm like, I wish this code would not run if it was written this way.
In Go, it wouldn't. Go cares about white space to an extent. I mean, that's kind of true. It adds some stuff so that it like doesn't care about it after. But like when you're writing the code, the white space actually does matter a little bit, not nearly as much as Python. Like it matters a little bit,
right?
And it ships with a formatter, so you don't get that sort of nonsense.
Oh my gosh. And speaking of Go, Go has lots of cool concepts in it. One of the things that I am constantly, when I talk to Go developers, primarily being, front-end web developers, so lots of JavaScript, lots of CSS, I talk about like asynchronous programming, and Go developers I think it's a rule that if you talk about promises or callbacks or something in JavaScript, Go developers have to stop and be like, well, in Go, we have coroutines. And they are a superior form of asynchronous programming. But they're kind of, a little difficult to wrap your head around, especially if you're not used to that environment. And so what would you say is easier to learn? Like Go, like coroutines or any complex Go concepts, or like CSS positioning or like CSS box model and like margin pattern? Like what do you think is harder to wrap your head around?
Well, first I have to actually, it's not coroutines, it's Go routines.
Yeah, you're right.
When you're in Go.
They are coroutines.
Yeah, they're coroutines. The more generalized idea is coroutines. But in Go, they're a little more specific, and they work a little differently. There's some additional Go kind of magic happening. Okay, so it's a good question. Let's take the like very basic example of fetching some data, right? So you're making an HTTP request, and you're fetching some data. In Go, the HTTP.get method in the standard library is synchronous by default. It won't do anything in the background. It'll just sit there and block till the network request comes back. To me, that's more obvious and easy to understand, right? There's no gotcha there. It's like I make the request and then I sit there and I wait and then it comes back and then I keep going. JavaScript land is nuts because it does all this extra stuff because you can't block the main thread. It's like, why can't you block the main thread? Well, sorry, you can. You shouldn't, right? You shouldn't block the main thread because that's rendering stuff on the screen. And that's like a whole bunch of extra assumptions that JavaScript is running in a browser, which used to always be true, is not true so much anymore. And so like you're writing a command line tool, and it's like, why do I have to explicitly await this thing? Shouldn't it just wait? And so anyways, I guess my point being, when I'm writing JavaScript, you have to remember, and you have to kind of know what's going to fire something off to be done in the background. And you have to know, especially if you're doing dynamically typed stuff rather than like TypeScript, you just kind of have to know, and you have to await it. And if you don't, you'll get like some weird errors where like you're trying to interact with a promise because you expected it to be raw data, but it's actually a promise. Whereas in Go, it's like, okay, if you want to do something in the background for performance reasons, then you use the Go keyword. So it's just like the inverse. Instead of awaiting things explicitly, we're going and doing things in the background explicitly. The challenging part, I don't think, is the which one of those you choose necessarily. Again, I think the explicit go do something in the background is a little easier to wrap your head around. I think it's just the fact that like concurrency and parallelism are hard to reason about. Just like always, no matter what you do, like those are just hard concepts. And so to go all the way back around to your question, are those concepts in whichever language you're using, are they harder than like, padding and spacing and stuff like that? I would say definitely. I think there's some of the more difficult, and I could almost say that objectively. I mean, I can't say it actually objectively, but I watch a lot of students go through our full like computer science and backend curriculum, and there's like a few places where definitely like the sticky parts, and it's like recursion and concurrency are like the two that I'd pick are like probably the hardest for most people.
What I have learned from our wonderful guests on this podcast and Adam is I think the essence of why people have struggled with CSS is really the idea that a lot of backend development or even web developers who dislike CSS or tend to be JavaScript developers is that a lot of the things you're doing with these languages is very imperative. You're like, I want this, give me that, go do this. You're writing all this like instructional bits of code. But with CSS, you can't do that. It is declarative. And on top of that, CSS, even though people talk about declarative, it's such a great thing, but it's more so what it represents. It's not just declarative in syntax, it's declarative in function. Because everything that you do in CSS, they're saying is a request. And so it's saying like, hey, we will try that. We will try to get to that you wanted to do. And you know what? It's probably going to come out that way, but it's not going to. And I think this actually circles back to what you were saying previously. You're talking about like how end-to-end testing can be easy. But the difficult parts is that if you look at like the matrix, like if you look at a matrix of like even doing something like testing a CLI, you're like, okay, who's going to be on a Windows device? It could be on Node 18, but it could be on a Mac on Node 20, or it could be on Linux on this one. So you can kind of like, it can get kind of large for like the human eye, but for like an end-to-end test system, it's pretty simple to like run through all these tests. When you want to create that same matrix from a front-end development standpoint, it gets unreal because you're like, what browser, what version, what computer, like all these like what screen size, like all this different stuff becomes just unreal. And that's why CSS in a way needs to say like, hey, I'm going to take what you want me to do and I'm going to think real hard about it and I'll try to respect you. But if it doesn't work out due to these factors, or like we're gonna do something a little wonky.
It's gonna do something. Like. I just don't know if you'll like it. Yeah.
Right. And then sometimes they're good scenarios, like the whole like CSS is awesome thing. Like the reason why it's jutting out is because you asked for like you asked for 200 by 200 pixels, but that text needs to flow 275 pixels. So what does it do? Does it go behind the box, or do we still want to keep the text legible? And so that's to me, I think that's why people don't like it, is because you basically have to say, it's like being on an airplane. You're like, I wish I was driving because I'm out of control. Like, like I think people just don't like letting go of the control that they get with imperative languages.
Yeah, I like what Lane was saying too. It made me think that, the side effects of writing a line of code, they can be much more wild in CSS. You can write something that just seems so, padding is a good example, or margin. Like, I'll just add some margin to this item. And then, I guess that pushes all the other boxes around it. Oh yeah, okay, now I need to go tap those boxes, and then you tap those boxes and they tap another box. And all of a sudden you're in that one of those scenarios where like you can't fix all the leaks. And so you just got a finger and a toe and a nose and all these different holes trying to hold it down. So when Lane and I talked on his show, he was like, where's the tooling at? And I think that's a really good point here, is that the tooling could really help articulate side effects. Like a really good example is like DevTools now will tell you like it. Let's say you set top 20 pixels on something, and it'll be like, this is not applying because your position is not relative or whatever. And you're like, oh yeah. But when you're authoring that, you don't get any of that feedback. Same thing with type information. I can pass a color red to the font size, and it just lets me do that, and it doesn't tell me anywhere in the editor that stuff's wrong. And so yeah, when we're working these other languages, we get a lot more feedback immediately about the single line that we wrote and about its impact and its viability and its possibility. And secondly, CSS, since everything lives in this big space and there's all these different screens and all these different contexts, one little line of code can cause so many side effects that you can't predict. It gets really frustrating. So yeah, it's nice to know that the command you're giving it has a simplicity to it, and that there's like an elegance to the least amount of side effects that will come from doing this thing. And CSS doesn't offer that. Yeah.
Difficulty. So I think it's really important to talk about like what we mean when we say difficult, but also like how we would like it to be interpreted. So I remember when I was first learning to code, there was, and maybe this was like unique to my cohort of CS students, but there was like some almost like gatekeeping or like you're better than another developer if you can work with the hard shit, like the difficult, hard to learn stuff. That's what real developers use. That's cool. That's the good stuff.
I dug a hole with a spoon, bro. No way. Oh
yeah.
my God.
Yeah, exactly. And then like later in my career, it's been a lot more of the opposite, where it's been like, wow, I hate Java because it's effing difficult to work with. Like I have to wrangle with this VM thing. I hate like the abstract classes. I want simple. I want it to be easy to work with. That's what's good for me. And so like when I say things like, CSS is I think it's, for example, easier to learn how margin works than how concurrency works. I think that's true. But that's not to like gatekeep and say, if you're going to be really good at CSS, you like that doesn't take, that takes less skill, or you shouldn't be paid as well as someone that's good at concurrency. That's like a whole different discussion, because again, like I've seen lots of talented backend engineers be like, front end's fucking easy. Look at this red button. So yeah, it's the ugliest button I've ever seen in my life. Nobody's going to convert on the landing page. We're not going to sell shit. We can't pay your salary anymore. So it's like CSS is really like, especially when you start mixing the idea of design and CSS, they get really hard, even though the building blocks can be simple. And I would agree, if this was the point you were making, David, that like in a lot of cases, declarative is better than imperative. If the abstraction makes sense, I would much rather write declarative code than imperative code. It's doing a lot of work for me under the hood.
That can be packed with lots of safeguards. Like CSS is guarding people from doing things wrong so well, because you can declaratively ask for it, and the browser can know internally if it even has time to run that animation. It'll drop a frame if it needs to, but pick it back up when it can. Yeah, it's really jam-packed with sort of handling the details of that request for you. It's nice.
I used to work on the Firebase console for Firestore, so like the data viewer editor and everything. And so I'd work with a lot of the Firestore like database engineers, and I was talking to this engineer. This guy came up to me one time and was like, "Hey, I'm building this little thing for like a demo," and he's like, "And I'm having a hard time." And like most of these guys are like PhDs, and like they are like very like they speak to you a lot of words that you're like, I'm gonna jot that one down to look up later, so if you mention it to me again, I don't feel so stupid. And so it's like lots of stuff like that. And but he walks up to me and he's like, I'm having a hard time here. Okay, he's like, I used to do front end development a long time ago, like back in like 2004 2005, and this is like 2017. And I'm like, oh, okay, so it's been a hot minute. And he's like, I'm just trying to get some JavaScript on the page, and it seems like you can't do that anymore. And he was like, you need other tools to put the JavaScript on the page now. And I was like, oh, you mean like a bundler? And he's like, yes. He's like, and he was like, and I can't just like, he's like, I need to use Node but I'm not writing Node. And
I thought Node was for backend development. Why do I need to run it to write React? Yeah.
And then I'm talking to him and he's like so confused. And then as I'm getting him set up with like Webpack and everything back then, he is basically like, he's like, back on my first project I did here at Google, he's like, I built this whole front end. It was great. I was like, oh, what'd you build? He's like, I built iGoogle. And I don't know if it was like long time ago, iGoogle was like this custom Google dashboard that was so ahead of its time. And then and he was like, yeah. And he explained to me how they made it. And it was like in this super like write Java, like, and it transforms things. It was like before Gwt though. And I remember him just telling me about this, and I was like, wow, like here's this person who's so smart, but yet the tooling, all this stuff, all the hurdles can be like, and exactly like to your point is, it's not a skill set thing. It's not who deserves to pay more. It just shows that like when you're out of your element, or like when things change so much so often, it can kind of just put you in a state where you just hands up and you're like, I can't do this.
Lane, have you seen the movie Office Space?
Yes, I saw it for the first time just like a couple years ago. I
What?
can't believe it took
Okay.
me so long to see it. Yes.
Seriously.
Okay, so you remember the scene where there's the fax machine, right? And it's like they keep smacking it, they get upset with it, but later they turn into gangsters, right? And they take it out in the back, they grab bats, and they just brawl out on it, right? Okay, so
Yeah.
I want you to grab a few CSS properties and brawl out on them right now. I want you just to just be like, I don't know, whatever position, whatever thing that you just like, I hate this feature, just never, and you just pound it, Let's hear it.
Okay, give me a second to gather my thoughts. I'm gonna have to think. Okay, probably float.
Okay, yeah.
I used float all the time when I first started doing CSS, and then I mean, to be fair, there weren't as many APIs back then, like Flex and Grid. But float is mostly a disaster. I feel like every time I use it now. And Flex and Grid, I feel like have mostly replaced the use cases for float. That's probably the worst one. I'm scrolling through on MDN to see what other ones I've have a
I too am
particular
bad at
distaste
float
for.
also. I just remember I was like, oh, hold on. I'll float left and then I'll clear right. Oh, crap. That didn't do shit. Okay. I'll clear left. Oh, that's not doing shit. Oh, here we go. Clear both. It's still in the same spot. What's going on? Oh, geez. I was just so much guess and check with float. I just had no idea what was going on.
Okay. I've maybe got one more, except it's not specifically a property. It's more like a thing I'm dealing with at the moment.
Love it.
So,
yes.
Like I said, boot dev has a very unique look to it. A lot of people arrive on the landing page and are like, what the hell is this?
Am I starting a D&D campaign?
Yeah, very weird. You can kind of tell the backend developers built it. There's, maybe some design decisions that aren't up to snuff. But anyways, we're in the process of getting the site redesigned now, working with a front engineer who has like really good design chops. And we've had this thing plaguing us for a while. We do like a glass morph animation on like our modals that pop up. So they've got that kind of like fuzzy blur through look. Mm-hmm. And we've realized that on like maybe 1% or 2% of our users' machines, again, coming back to how you can't know what everyone's viewing your thing on, for some reason, I think their machines are not using like graphics cards to render.
They're getting a fan to spin up, huh?
Oh, yeah. Not just a fan to spin up, but like it gets choppy and laggy. They can't scroll very well. Again, like we can't even reproduce this on like some of us have like some older PCs we've tried to reproduce on. We just can't. So in the redesign, we're like, we need to probably just stop doing this because it's been such a pain in our ass. So there's something about like, I guess the complaint boils down to like, you're allowed to do a lot of stuff in CSS, but debugging performance across all the machines can be tricky. And like, just to give another analogy, I know we're kind of going over on time, is Firebase. One interesting thing about Firebase, even though I don't really love it as a product for other reasons, one cool thing it does is it forces you to have fast queries. Like you have to have your indexes in the right, set up in the right ways such that when it's time to read them, they'll be fast, which is nice. Whereas apparently, I didn't even know this, in CSS, you can write some hairy shit that's going to run real slow on some machines. And you don't really get any feedback on that. Yes. Yeah. So yeah.
I just went through this, dude. On my side, I had a dialogue and it was using view transitions. You click an image and it like zooms up into full screen, and I had a blurred background. And it was chunky, terrible, nasty ugliness, and I got rid of it and it smoothed it way out. I had another performance issue on my page. I was having 2-second recalc styles on my work machine. It's like a 2017 machine, which was causing all sorts of things to lag. And it turned out the solution was to remove some has selectors that I wasn't even using. They were in the page, as like a at supports backup thing. I can't remember exactly what I was doing, but dude, that just some has queries caused. So when the page got reflowed and it had to recalculate all the styles, that particular set of selectors was dragging down the page. And when I got rid of them all, I got 7 millisecond recalc styles. I went from 2-second recalc styles to 7 milliseconds. And I looked at the engineers because I was working with Chrome engineers to debug my site. I was like, guys, my site is slow. It's not cool. I need to fix it. Like I should have a fast site. And we're looking at it. And once we found it, which literally was by commenting things out. We were commenting chunks of code out, trying to figure it out, because all we knew was the report that it was a long recalc style, and not even them could go tell me what it was. And so later we ran the selector stats feature, which is so new in Chrome DevTools. If you open up and do a performance review, you can hit the settings and say selector stat performance. I urge everyone to run this, and it will surface to the top your most expensive selectors. And look there, if there's like a couple that are just nasty gnarly up there, check them out, see if you can make them faster, and you might see just better paint times for every time your site has to get reflowed. Just boom, increases in performance. And yeah, it's not fair. How is a normal person supposed to do this if they don't have access to the team there? I've been, since this happened, I'm like asking around, I'm like, so the answer to this question cannot be meet with engineers that know how to do this, or comment out code until you find them. Like, that's not good enough. Tooling needs to surface this crap to people and be like, huge recalc detected, like abnormal activity. I mean, you can see it in the performance chart. You get the flame graph that's just fat and long, right? You're just like, whoa, why did it take so long? But yeah, CSS performance is definitely one of those things we're supposed to be able to trust it. I should be able to ask for a filter blur. I should be able to animate a glass morphism thing without pain or without knowing what the internals of the engine are doing. But yeah, one of the realities is you kind of do sometimes have to understand what is it doing so that you can work with it and use it in a way that it's happy about, and sort of like pacify its different, which again is what we do in JavaScript, right? You write the function first, and it works fine, but then you later find out there's a way to do it faster. And so then you make it faster, and then you realize users are interacting with your function and they're throwing random shit into your function. You're like, okay, so now I have to have all these edge cases. And that's why Node is slower than Bun.
I mean, this is that last one caught up to me as I started. This is an important point to note. Like, fundamentally, this is about abstraction, right? The performance has been abstracted away from you, which makes it really hard to debug when it matters. And I just want to point this out, that declarative is good, but it is by definition an abstraction, because the world is not declarative. The world is imperative. Right. The way computers work is imperative. So I'm a big fan of declarative code, but it is important to understand that, like, the same goes for SQL on the backend side. Like, SQL is very declarative. You write this query, and how fast is it going to run? I don't know. Like, depends where it's running, how it's running, the data set. And so you need like really incredible tooling to kind of make up for that.
Yeah. I took a class in college where we would have to calculate the length of a query depending on like certain factors. Like in a word problem, it would be like, Bob has this much data in his data set. He's going to write a query that like does this. Like, how long is this going to take? And it was very difficult. So like you get this, like I think throughout the whole semester, pretty much like 80% of our grade came down to probably like 40 of those questions. And so everyone, you were like, oh, I don't know.
Hey, how come imperative databases aren't cool? Why isn't there a database that everybody loves where you do all the work? You stick it in, you get it out yourself, you stop using the query language. Why not?
I think because that almost, like, the thing that follows from that is writing your own database. The whole point of a database is to give you an abstracted query layer. I don't even know what it, like, I think that thing exists. It's called like writing to files on disk and then reading them.
It's like PHP flat files. Yeah.
Yeah, it's like io.read, io.write. There's your imperative database.
That's actually what I was thinking. As soon as Adam said that, I was like, I think that's just doing it yourself, which, eventually at some point in your life, even whether you know it or not, there's multiple things that you make yourself. CMSs, databases, everyone does it at some point. JavaScript frameworks, apparently, it will be one as well. You must make that if at least accidentally.
I'm writing a markdown formatter right now because I'm very frustrated with the state of markdown formatters. So we'll see how it goes.
You know what?
Love it.
Report back to me on that. Awesome. Well, Lane, that was a very enlightening. It's always amazing to get someone from, sort of the other side of the aisle, like to come over and give you insights into your world. So very appreciative for your time and everything today. And you can catch Lane over at his podcast as well, with Boot Dev, just Boot Dev into YouTube or Boot Dev into, whatever your preferred search engine is. And it will, just show you all the amazing things. Especially if you do want to learn Python, then, give Boot Dev a try. So thank you for joining us, and we will see you all in the next Bad at CS episode.
Visit Bad at CSS.